Good morning, students. Today we'll start our new topic, increasing and decreasing functions. Okay? If we see the name of function increasing and decreasing, so from its name, it's clear that increasing function. If we draw its graph, it is going only up only. It will go up only. From its name, it's clear. If we draw a graph of any function, it goes up only. Then it will be increasing function. And from decreasing function, it is clear that if we draw its graph, it goes always down. Okay, so from name it's clear, increasing, decreasing. Now let's see if we have given graph of any function like this. So here what happens? This graph is going on, going up, and then for some values here it is constant, fixed. Its value is fixed, and then again going up. Okay, so this type of function is called increasing function. Okay, for some values it is constant, fixed. Then here this graph is going up only, always. For different these values are here different, so it is strictly increasing function, increasing and strictly increasing. Then here this graph is going down, then here it is constant and again going down. So this graph showing a decreasing function. This is graph of a decreasing function. Then here this graph is continuously going down, so it is strictly decreasing function. Okay, so we have increasing, strictly increasing, decreasing and strictly decreasing functions. So from graph we can identify function is increasing or decreasing, strictly increasing or decreasing. But if one function is given, then how to find that function is increasing or decreasing? For every function we cannot draw the graph and then we'll check function is increasing, decreasing. So a function f of x is said to be increasing or decreasing in its domain. I is an interval in its domain. Okay, in the domain one interval is given, say I. So this function f of x is said to be increasing, decreasing, strictly increasing or strictly decreasing in this interval. What are the conditions? So if we see here, suppose we take one value here x1 and here x2, then what happens? Value of function at this point is this f of x1. Value of function at this point x2 is this, that is f of x2, this value f of x2. So what is happening here? X1 is less than x2. If we relate x1 x2, x1 is less than x2. And what is this implies? F of x1, value of this f of x1 is y1, value of f of x2 is y2. The y1 y2, what is relation between y1 y2? Y1 is less than y2, means f of x1 is less than f of x2. So for this value is x1 x2, x1 is less than x2, f of x1 also less than f of x2. But suppose your x1 x2 are here x1 x2, then what happens? Value of function is same, constant, means we can say if x1 is less than x2, here x1 x2, the relation is same, x1 is less than x2, but in this relation is both values are same. So when x1 is less than x2, and this implies f of x1 is less than equal to f of x2, either less than or equal to, and even when it happens, then we can say f of x is increasing function. Then f of x said to be an increasing function. Check this condition for increasing function. If one function is given, then we take two values in its domain such a manner, x1 is less than x2, and we find values of function at that point, and if we get this value less than or equal to f of x2, then we can say function is increasing function. Check it. Then here what happens if we take x1, x2, then value of f of x1, value of f of x2. So x1 is less than x2, and this implies what? F of x1 is less than f of x2. Now for values of x1, x2, f of x is not same. For two different x1, x2, f of x is not same. It is always changing. So means f of x is always less than f of x2. Then f of x is said to be strictly increasing function. Then f of x said to be strictly increasing. F of x is always less than f of x2. Okay? So increasing, strictly increasing. Then here for some values of x1, x2, what happens? Again, if x1 is less than x2, and this implies what? Value of function f of x1, f of x2, now y1, y2. Now y1 is more than y2, means f of x1 is more than f of x2. Okay? And for some cases it is constant also, it can be equal. So when x1 is less than x2 and f of x1 is more than equal to f of x2, then your function is decreasing function. Okay? The function will be decreasing function. And the same way, if we have graph like this, x1 and x2, if x1 is less than x2 but f of x1 is more than f of x2, then it is strictly decreasing. Okay? So these are the conditions to show or to find out a function is strictly increasing or only increasing or decreasing or strictly decreasing. Okay? Suppose f of x is 2x plus 3. So for real values of x, this function is strictly increasing. This we want to show. Show that this function is strictly increasing. Okay? Suppose that x1, x2 are two numbers belongs to set of real number. Okay? कैसे हैं? Such that x1 is less than x2. Okay? Those x1, x2 are true real numbers where x1 is less than x2. Now, then what happens? x1 is less than x2. This implies. Now with the help of this condition, x1 is less than x2, we will reach to this function. We bring this function here. So whatever number is multiplying with x, we will multiply here. So x is multiplied with 2, so we multiply by 2 both sides. Okay? See, when two numbers are like this, one is less than other, and if you multiply by any positive value, by positive number, the relation remain same. If 1 is less than 2, if you multiply any number here, positive number, 5, so we get 5 here, and here 10. So again this relation is same. But when you multiply both sides by any negative number, suppose you multiply here by minus 5, you get minus 5, and here you get minus 10. Now what happens? Minus 5 is more than minus 10. So when we multiply in any inequality by negative number, this sign of inequality will change, and if you multiply by positive value, sign remain same one. So 2x1 is less than 2x2. Then here we have plus 3. So we add both sides, plus 3, and we add 3. If it is less than this, so if we add both sides 3, relation remains same, less than only. So 2x1 plus 3 is less than 2x2 plus 3. Now what is 2x1 plus 3? F of x is 2x plus 3. So 2x1 plus 3 will be f of x1. If you replace here x by x1, what we get? f of x1 equal to 2x1 plus 3. When you replace x by x2, then f of x2 is 2x2 plus 3. So it is your f of x2. So what happens here? X1 is less than x2 and f of x1 is less than f of x2. Means this condition is satisfying. It means your f of x is strictly increasing. Okay? So like this we can show given function is strictly increasing or decreasing. Okay? But our chapter's name is application of derivatives. Means we have to apply derivatives. So here to show function is increasing, decreasing, we have to apply derivatives. So how will we show a function is strictly increasing or decreasing using derivatives? Okay, so that we'll see now. Okay, so first you can note down this and then we'll see how to show function is increasing, decreasing using derivatives. We know that derivative of any function at point x is the slope of the tangent of the function at that point x. But suppose we want to find derivative of function at this point. Okay? So what we'll do? We draw one tangent at this point and find its slope. So its slope is same as derivative of that function. Okay? Geometrical meaning of derivative is what? Slope of tangent at that particular point is derivative of that function at that particular point. So if we draw tangent at this point, okay, then its slope will be its derivative at this point. Okay, and slope we denote by m, that is tan theta. Okay, so dy by dx, or you can say f dash of x, tan theta. Now what is the value of tan theta? In this case, your angle theta is acute. The value of tan theta will be positive. In the first quadrant, tan is positive. So f dash of x will be more than 0. Tan theta is more than 0. Okay? If we draw tangent here at this point, then its slope will be tan theta, and theta is acute. So value kind of will be more than 0. Okay? So f dash of x is more than 0. But here, if we draw here tangent, then it is parallel to x-axis, and slope of x-axis is 0. So in this case, tangent slope becomes 0. So f dash of x is more than equal to 0. Okay? So if derivative of function is more than equal to 0, your f of x is increasing function. So to show a function is increasing, find its derivative and it should be more than 0 or equal to 0. Okay? In this case, if we draw tangent at this point, again theta is acute. So f dash of x means tan theta will be more than 0, and for every value, at every point if you draw tangent, it will be more than 0 only. So when your f of x derivative is more than 0, then your function will be strictly increasing. Okay? Then f dash of x, here in this case, if we draw tangent here, then theta. Now in this case, theta is obtuse. So m equal to tan theta, value of tan theta will be less than 0, means f dash of x is less than 0. Okay, and somewhere it can be equal to 0 also, because its value is constant. So f dash of x is less than or equal to 0, then your function is said to be decreasing function. Here always at at any point if you draw tangent, then theta will be obtuse always, and in second quadrant, okay, theta obtuse means more than 90, less than 180. So in second quadrant tan is negative, so always tan theta will be less than 0. So f dash of x, derivative of function is less than or equal to 0, then function said to be decreasing. And if f dash of x is less than 0, then function is strictly decreasing. If you draw a tangent or a tangent, angle will be always obtuse only. So using derivative, how can you show function is strictly decreasing, strictly increasing, or increasing, decreasing? We will find its derivative and we'll show that it is more than or less than or more than equal to or less than equal to 0. Okay? Sometime your function can be like this. Here it is increasing, then again decreasing, and decreasing, then increasing, then so sometime function in particular interval, here in this part it is increasing, but here decreasing. So if we talk about this interval, so in this interval it is neither increasing nor decreasing. When suppose one interval is given a to b, closed interval, then in its sub interval the function is in one interval increasing, in one sub interval decreasing, then in this interval function is neither increasing nor decreasing. Okay? In the sub intervals of an interval, function is increasing or increasing and decreasing. So in this that given interval, function cannot be increasing and decreasing. We cannot say it is increasing only or decreasing only, because sometimes it is increasing, sometimes decreasing. In this interval it is increasing, in this interval decreasing, but in overall in this interval neither increasing nor decreasing. Okay? Now let's see some examples how to find out function is increasing using derivatives. Now we have a question. We have to show y equal to 4 sin theta upon 2 plus cos theta minus theta is an increasing function of theta in the closed interval 0 to pi by 2. Okay? In this interval we have to show this function is increasing function. So increasing function condition is derivative of this function should be more than 0 in this interval, or more than equal to 0. For strictly increasing should be more than 0. Here it is given increasing means this its derivative can be 0 or more than 0, more than equal to 0 in this interval 0 to pi by 2. So first step to show any function is strictly increasing or decreasing, find its derivative. Okay? So if we find, we have this, so differentiating both sides with respect to theta, we get dy by the theta is equal to, here we would apply quotient rule. So denominator 2 plus cos theta as it is into derivative of numerator, it will be 4 cos theta minus 4 sin theta, numerator as it is, into derivative of denominator. So derivative of 2 plus cos theta is minus sin theta upon denominator square, so 2 plus cos theta square minus derivative theta is 1. Okay? So now it is equal to 8 cos theta plus 4 cos square theta plus 4 sin square theta, and if you simplify this part, so this can multiply here, so you get 2 plus cos theta square upon 2 plus cos theta square, square of 2 plus cos theta. Okay? Now you can simplify this part first. So 8 cos theta plus, now if you take 4 common, then we get cos square plus sin square theta minus, this will give, using a plus b whole formula, 4 minus cos square theta, because it is negative here, minus 4 cos theta divided by 2 plus cos theta square. So it will be 8 cos theta minus 4 cos theta. 4 cos theta. Then cos square sin square is 1. So 4 into 1 minus 4 0 minus cos square theta as it is. Right? 4 minus 4 becomes 0. So 8 cos minus 4 cos and this minus cos square upon 2 plus cos theta whole square. Okay? So when we find derivative of any function, so that derivative will write in the form of product. That expression should be in the form of product. Everything should be in product form. From that we can see directly, and you can say the function will be, this value will be always negative or positive. We need only sign. Its sign will be negative or positive. We only have to find sign. Its sign will be negative or positive. We don't need its value. So what we can do here, cos theta if we take common, then we get 4 minus cos theta divided by 2 plus cos theta whole square. Okay? So now everything in the product form, cos multiplying this 4 minus cos and divided by square of 2 plus cos, here multiplication. Okay? So now we can see the values, how cos theta value carries values 4 minus cos theta, value of 4 minus cos theta and value of 2 plus cos theta. Which values will be negative, which will be negative, positive. Then we can, if we multiply three numbers like this, suppose, okay, these two are negative and it is positive. So what will sign? If one is positive, one negative, upon here positive, what will sign? That we can find. So now we'll see the sign of cos theta in this interval. In the first interval, 0 to pi by 2. Sorry, the first quadrant, 0 to pi by 2, and where 0 and pi by 2 also included. So cos pi by 2 is 0. So this value can be 0, and it is in the first interval quadrant. So always more than 0. It means what you can say, cos theta is either more than or equal to 0. Okay? Then value of cos theta is always lies between minus 1 and 1. Minimum value minus 1, maximum value 1. But here it is interval given. So minimum value if you see, cos 0 and cos pi by 2. Cos 0 1, cos pi by 2 0. So 4 minus 0 4 only, and 4 minus 1 3. Means this is always positive. 4 minus cos theta will be more than 0 always for this theta. Then 2 plus cos theta, again cos can have minimum value minus 1, maximum value 1, cos 0 and 1. So 2 plus 1, 2 plus 0, positive only, and its square is there, so always positive, cannot be 0. So 2 plus cos theta, square of 2 plus 1 is always more than 0. So we have these three conditions for all theta belongs to 0 pi to pi by 2 in this interval. This values we have. So what will be value of this? It is more positive, it is positive, divided by positive, positive, positive only. It is positive also, but it is 0 also. So 0 by something, positive value 0. It means dy by d theta can be more than equal to 0. Okay? These values will give you dy by theta more than equal to 0. It means the given function y is increasing function in the interval 0 to pi. So like this you can find derivative function and write that expression in the form of product. Then see the values for the given interval or whatever given, for that what will be its values, and then according to the sign we can find out derivative is negative or positive. Okay? This is very important question. This question carries 4 marks. This topic carries 4 marks. One question can be from this topic of 4 marks. Okay? Okay students, in the previous question, one function was given and one interval in which we to show function is increasing, है ना? Now we have to find one interval where function is strictly increasing or strictly decreasing, है ना? Previous question interval was given and we have to show function is increasing, but here in which interval, for which interval this function will be strictly increasing or strictly decreasing. This type of question carries 4 marks, है ना? And very very important question. One question can be in the exam. So here first step for solution of these questions. First we will find derivative of function. Okay? First we need derivative of function. This will be first step. So first we differentiating with respect to x, we get minus 6x square minus 18x minus 12. Okay? Then second step will be factorize it and find its factor. So if we take minus 6 common here, then we get x square plus 3x plus 2. If we find its factors, yeah, multiplication should be 2 and some 3, so x plus 1, x plus 2. How to factorize? We know very well, na? So x plus 1 into x plus 2 will be factors of x square plus 3x plus 2. Okay? This is our second step, means find derivative and factorize it. Now second step will be when this f dash of x will be 0, at which point this derivative becomes 0. And actually what we are doing, what we are finding, suppose the graph is going like this and sometime it goes down after one place, after one point it goes down, or it is going down and again it raises. So we are finding at which point, if we draw tangent of tangent of this curve, that will be parallel to x-axis. And here if we draw tangent, then its slope means f dash of x will be 0 because its slope and this its slope of x-axis will be same and slope of x-axis is 0. So f dash x will be 0. So we are finding at which point this derivative becomes 0. So if f dash of x is 0, then x will be, if it becomes 0, x plus 1, x plus 2 equals 0, and it is reduce, x plus 1 is 0 or x plus 2 is 0, then x will be minus 1 or x will be minus 2. So we are getting 2 points at which derivative becomes 0, means we are getting 2 tangents of this curve at minus 1 and minus 2, which will be parallel to x-axis. Okay? Now second thing, what we need, where this function will be strictly increasing. So at which, in which interval this derivative of this function will be positive, or in which interval this derivative will be negative. So for that, these 2 points will give you intervals. So on a number line, okay, this number line, we plot these points minus 1 and minus 2 in order. Means first minus 2, then minus 2. So these 2 points divide this number line in some intervals. One interval is this, second interval, third interval. So these 2 points divides this line into 3 intervals. Okay? One is minus infinity to minus 2, one is minus 2 to minus 1, one is minus 1 to plus infinity. Okay? These 3 intervals we are having here. So in this interval function is increasing or decreasing, that we will find. In this interval what will happen? So for that we will see the sign of this derivative. In this interval, what will be sign of this f dash of x? Okay? Now what we will do for that? Simple way. In this interval, take any one point less than minus 2. You can take any point less than minus 2, say minus 3, minus 4, minus 5, any point can be there. Suppose if you take minus 3, then what happens? minus 3 plus 1 will give negative value. Minus 3 plus 2 negative value, negative, negative, negative. 3 negatives means f dash x is less than 0 where in the interval minus infinity to minus 2. ठीक है? Then in this interval minus 2 to minus 1 any one number we can take, say minus 3 by 2 है ना, minus 1.5 minus 1.5 plus 1 is negative है ना. We need only sign, we don't bother about its value. Minus 1.5 plus 1 negative value, minus 1.5 plus 2 then negative value, positive value, minus 1.5 and plus 2 positive value, positive, negative, negative, get positive value. So f dash of x is more than 0 in the interval minus 2 to minus 1. Then the third interval minus 1 to infinity, positive infinity. Any one point you take, suppose that 0, take 0, 0 plus 1 positive, 0 plus 2 positive, 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 negative. So f dash x is negative in the interval minus 1 to infinity है ना. Mostly we get alternate sign है ना. In this interval we are getting negative, then here positive, then here negative. Mostly, but not always. Sometimes can be same sign, negative, negative, positive, positive like this. But mostly we like alternate sign. Check. So in this interval, the derivative is less than 0. In this interval, more than 0. In this interval, less than 0. It means in this two interval, your function is strictly decreasing. Your derivative is 0, less than 0. So in this two interval, your function is strictly decreasing, and here function is strictly increasing. So f of x, and since f dash of x is less than 0 in the interval minus infinity to minus 2 and minus 1 to infinity, therefore f of x is strictly increasing in, take union of this two interval minus infinity to minus 2 union minus 1 to infinity. In this two interval your function is strictly decreasing, it's less than 0, it's strictly decreasing. Then f dash of x is more than 0 in the interval minus 2 to minus 1, therefore f of x is strictly increasing in the interval minus 2 to minus 1. So like this you can find the intervals where function is strictly increasing or strictly decreasing or only increasing, decreasing. In case of only increasing, decreasing, this points also we can include, means this open interval becomes closed interval. This side it will be closed, this side will be closed if we have only increasing or only decreasing. But in case of strictly increasing or strictly decreasing, we'll have open intervals. Okay, so like this you can find a function in which interval will be increasing or decreasing. Okay, simple steps are there. First find derivative and factorize it. Then find the points at which your derivative becomes 0. Just put derivative 0 and find the values of x. Now this x will divide the number into some intervals that we get. If there are 2 points, we will get 3 intervals. If there are 3 points, we get 4 intervals. Then see the sign of derivative function in this particular intervals. That will give you function is increasing or decreasing. Okay? These are questions. These questions are very important questions. 4 marks can get easily. Simple thing. Just factorize, differentiate, factorize, find a values of x, and then see the sign. Okay?